Okay, so some of the other things that you might find on a legend of a map, if you're going to make a geomorphic map of a riverscape, are geomorphic units. These are, the real big sort of building blocks, basically the polygons. If I was to get out my my pen here and I was to start drawing, right? I might call the channel, right, one geomorphic unit, and then I might call, let's say, not great on my color choice here, right? But I've got these big floodplain areas, right? And so these things would get mapped as polygons. And so it's important for you to um, to understand what we call those things. So geomorphic unit, its definition, it's a landform that's a byproduct of erosion and deposition of sediment. Okay. Fluvial geomorphic units are just those that are created by water, right? Same sort of thing. So here's a nice example. There's a pool, those are units. There's a point bar, there's a point bar, those are units. And then highlighted here, this is a riffle, okay? So for our purposes, they're spatially continuous areas that can be topographically defined. You could, if you want, kind of let those be fuzzier boundaries if you wanted to define membership in the riffle class or membership in the point bar class as a probability, right? And so the probability might be high or 1 right here in the middle, but then out towards the edges. And one of the hallmarks of geomorphic units in rivers is because things are organized and smeared out across a riverscape in a streamwise, a upstream, downstream fashion, we tend to often have blurred boundaries longitudinally or downstream. And then laterally, we can have blurred, but sometimes we have sharp, right? And so this is just very characteristic. So here are some examples of, here's a floodplain feature. So that's a floodplain is a geomorphic unit. A terrace is a geomorphic unit. On the floodplain, we can further subdivide things out, right? We got a flood channel, levee, crevasse splay. Crevasse splay is just where you have a levee, a natural one, where you get a breach in it, and then you get sediment just kind of puking out, almost like it does from an alluvial fan when an alluvial fan enters a trunk stream. So we tend to draw these as polygons, like I mentioned. And this is a sort of horrific little flow chart that can help you work through definitions of these, okay? And so let's just kind of keep it simple first, and we're going to start, this is tiered. So we're going to start with fewer categories, simple concept. Then we're going to split, get more categories, but more useful differentiation. And then we can split again, okay? And the bases for splitting are going to be stage height, the shape and the form, and then morphology, and then we can optionally add on, kind of roughness or vegetation. Like that's a vegetated bar, or a vegetating bar, or an unvegetated bar. That's a sandbar versus a gravel bar versus a boulder bar, etc. Okay, so starting with that tier 1, we've been through this, right? Come in, you land, and really what you end up with are these sorts of geomorphic units, right? It's either a channel or it's a floodplain. These would be part of the valley bottom, or it's terrace or a fan, okay, or hill slope. And so the building blocks of the valley in this case are, well, the channel, the floodplain, yeah. The terrace, the fan, yeah, those are part of the valley. But the building blocks of the valley bottom, it would just be the channel and the floodplain, okay? So once you've done that, I mean, that's pretty easy. That's a nice, simple map, not very complicated, right? Here's some examples of these in some contrasting riverscapes, right? So the channel, little occasional floodplain pockets, bunch of fan, right? So we got a narrow little valley bottom, here a narrow valley and valley bottom, but here, because of this fan, a wider valley. Contrast that with this area, and it's kind of pinched in between fans on both sides, but you've actually got a fair bit of floodplain. And then here, there's a ton of floodplain. This anastomosing system is just working itself around. So when we move down to tier 2, we're going to talk about shape, and form. And shape's a little simpler, so we'll start there. Just think planar, convex, concave. Okay. So I don't know, maybe you've got six-pack abs, right? Planar. Concave, suck your tummy in. Convex, well, yeah. So anyhow, this is basic shapes, right? Another way of thinking about this is if we put water on this, it would pool and collect in the concavity. It would shed off in the planar and shed off in the convex, right? But here it would shed away, and here it would just sort of move along uniformly. So we can differentiate concavities, convexities, and planars. Okay, those are basic shapes. Form. Well, it turns out partly because rivers are stretched out, in a streamwise fashion. It's good to look at those cross-sectionally versus longitudinally when we think about those shapes. So a classic convexity, like bars, like a mid-channel bar, we'd call a mound. And that's because, if you put a marble on top of it, it would roll off, right? It would roll off in the downstream or upstream direction. It would also roll off in the lateral direction across it. It's convex in both ways. Now, a riffle is a really special example of a bar, okay? But it basically is a dam. And so it is a convexity as you move from upstream to downstream, right? But rivers have thalwags, and the thalwag is the deepest part, and the thalwag actually comes up and over, right? So it's convex. But by definition, the thalwag is the narrowest, or sorry, the deepest part of the channel. And so it's actually concave in cross section. Another example of this in nature, a pass, right? When you go up over a mountain pass, it's that special part of the ridge um, where it dips, in between two ridges that are rising up. And so in rivers, these basically act as dams for water, and water is forced up over the top of them. Now we've got planar features, and those can be really steep, like a bank or an avalanche face on the edge of a bar or the edge of a bar that's been sculpted. Or they can be really gradual, like a big plain bed, glide, or a run, etc. So um, now concavities, the easy extreme one to think about is a pool. If I drain the river, would there be a puddle there? It's concave in longitudinally, upstream to downstream, and it's concave in cross section. But we find examples of what we call troughs, as opposed to just bowls, where if you drain the river, there wouldn't be any water there anymore in these. And so chutes, which dissect bars, are a good example of these little sort of dissection features. So they tend to be planar longitudinally, whether it's steep or shallow slope, but they are concave in cross section. So we can map these, right? We can come to a riverscape, and you can map out based off of these sorts of stuff pretty simply. Okay, so what we're seeing here is the pools, right? The true bowls, right? In blue, and in orange, you're seeing some of the bars, the convexities, and then the yellow, some of the planar features in between. Then we get up onto the floodplain features, and then in this case, a fan. So tier 3 is all about breaking things up a bit further. And what you end up with out of this mess, so don't freak out about this just yet, are the names you guys are probably used to. What I keep alluding to: a pool, a bar, a riffle, that sort of stuff. Okay, this is just how you get there. The two sides here have similar attributes, but they're slightly different because this side is dealing with floodplain. Turn on my laser pointer. So this is turning on floodplain. So we look at surface morphology, the position on the floodplain, forcing, longitudinal continuity, and the orientation. Versus on this side, we're looking at in-channel units. And we're just going to focus our attention today to in-channel units. So we have low flow water surface slope. We have position, forcing, low flow relative roughness. This is just the measure of water depth relative to, right? You take your water depth and you divide it by your roughness height, or sorry, your roughness height, and you divide it by your water depth. So if you got a little pebble on the bottom of a stream, and let's say it's an inch in diameter, but your water is 2 feet above that, right? You've got really low relative roughness. Now, if you got a boulder that is 24 inches in diameter and your water depth is 18 inches, right? You've got high relative roughness, actually greater than 1. Okay, so that's that. What you do in most cases, oops, is you sort of come down through this. Am I in the channel or am I out of the channel? And then if I'm in the channel, you don't actually have to identify all of these to make them useful for differentiation, and I'll show you that. So these are for your reference. You can pause here if you want, but these are just the definitions of those attributes that we just talked about. Okay, so basically these 5 things. And then the different types, what is meant by those, okay? Now this table, by contrast, is really intimidating. This is one of a bunch of tables in a paper that helps walk you through how to find these things. So what I want you to recognize is tier 1, okay? Come in, and at tier 2 we define planar. So tier 1 we come in, we're in the channel. Tier 2 we're planar, and then these are the choices, okay? These are the attributes, 1, 2, 3, 4, 5. And what you end up with, if you apply these, right, it's a similar map, but you're able to break it out into more specific things. Who cares? Why would I want to, know so think about this as the difference if, like, I just look out at you guys as a bunch of students in the class, and you're all just students, right? You're not faculty, you're students. Okay, maybe that's like my tier 1. Well, then maybe I want to like break out you as students and understand, like, okay, well, which of you are some major? Which of you are male, or female? Which of you are, different ethnicities, etc. Right? This further discriminating of the type, these more specific definitions, give us better inferential power to infer what sort of processes must be taking place there. Okay. And so when you do that and you apply it to different settings, you get different assemblages of units, right? So here I've got 3 different river types that it's been applied to. And in this one, it's dominated by plain bed features, right? And versus this one where it's a much more even mix of those different shapes, okay? And these are actually the 3 sort of river types that we looked at a little bit earlier that were mapped. So if you land on a riffle and you know it's a riffle, well, you're done. Okay, you can read it, you know what a riffle is, and then there's a bunch of stuff, like I said, that you get to infer about the processes that must be taking place, as well as some of those key attributes. If you don't know that and you need sort of a dichotomous key for helping you out, come back to our horrible tables, okay? So I land on that riffle and I know it's a convexity. But then what? How do I use these attributes to figure out which of this, whole long list of, geomorph trivia of bars that it is? Well, let's just walk through. Okay, yep, I'm in a channel. Boom, boom, fine, fine. And you guys could do this, right? So if we paused right here, you could print this map out. And you could draw everything that's in channel and everything that's out of the channel. So why do you do that? Print this blank sheet out, okay? So what are you gonna do once you've printed this? What you're gonna do is just read the topography. These are contours, right? Tell me where the channel is, tell me what's out of the channel. Pretty simple. Okay, assuming you've gone and done that, there you go. So you get something like this. Now actually your green would extend all the way across this whole thing, right? But here's the in channel, okay? So that's tier one, right? That's basically you've done this piece, okay? And we're kind of trying to imagine one of these riffle crests, all right? So let's go to tier two, right? The shape. Well, you can do this as the convexities, concavities, or planars, or if you want, you can do it as the forms. But to keep it simple, let's just I'd recommend you print out this same page again, right? And then you do it in this order: map out the concavities, then map out the convexities, and then map out what looks planar. And then whatever's left in between, you can call transition. So go ahead and do that, and then hit play when you're ready to go again. Okay. So this is a model that is trying to do the same thing that you just did, but just curious to see if you get something sort of similar, right? So basically, if you start with those concavities, right, there's a bunch of little pocket pools, right? And you might have a threshold for whether or not you bothered with these, right? What's the term would be residual pool depth, right? How deep does the puddle need to be in order to get called a concavity? So maybe you don't pick up some of these, but this is helpful for you to see at least topographically what's defined. And then the yellow is just kind of muted, right? But if we look for the areas that are less muted, that are sort of the inverse of those pools, right? That's kind of what it's trying to see here in orange. And then some of the muted in between. Now, this isn't necessarily, you're not necessarily going to have the exact same thing, but you should get some of these basics. So if we switch that into form, we talked about what the definitions of these are, and when we were developing algorithms to define these things, this form distinction became really helpful. And I mentioned earlier what a thowag is, but you may not remember or know what a thowag is. And so a thowag is just the deepest part of the channel. Okay, so if I'm coming across here, let's just turn on a laser pointer. Coming across, no, I can still get deeper, still get deeper, still get deeper. I can still get deeper, still get deeper. Oh, I'm going uphill. Well, okay, so in here, right? That's the thowag. That's the deepest part of the channel. Now on a planform map, right? Thowags in really boring channels might just run straight down the middle. That's almost certainly an engineered channel. Thowags tend to sort of bounce around as momentum shifts from one side to the other, and usually on the inside bends is where we start to see, lower energy and bars develop. The extreme example of that is in the meandering planform. Okay, so let's do a little exercise. Let's have you print this page out. Okay. Another topo. By the way, where these are coming from, this is bathymetry that is in the Logan River, right along. Actually, this little levee here is if you're walking along the river trail in the golf course. Okay, so the clubhouse is over here, and then this is the lower part. So go ahead and print that out. Hit pause and attempt to map the thowag. Where is the deepest part of the channel? Hint, flow is from right to left. Okay, assuming you've given that a try. Up top here, what I'm showing you is actually from a model that's derived this. So just for reference, I've put the center line in red. So hopefully you can see that. And so this is the center line coming down that channel. And then the thowag goes in here, and see how the contours are pointing upstream, right? So I'm coming down and it's kind of moving around. Depends on how well you can see the gray, right? It's pushed up on this outside bend, comes down through here, shifts onto that outside bend, goes through, right? And it's going through the deep spots, going through the pool. So that would be your thowag. Now you may have noticed that on here I've got mapped some little secondary thowags that feed in. Well, these are on the edges of little bars that have gotten attached, and are starting to form little shoot cutoffs. So those, you don't necessarily have to have mapped those, but those are real. Now, in healthier riverscapes, the thoweg bounces around and departs from the center line. Here you're getting a little bit of that, and it's why when you see those departures, that's where you're going to tend to see concavities, pools, and convexities, bars. Where the thoweg and the center line are right on top of each other, that's where you're going to tend to find plane bed morphology, planar features. So having you do that little exercise is helpful. This is further downstream. This is actually topography. Let's see if I can explain this. Yeah, I can. Right up here, I think, is roughly where the dog park is, and right here is where the new trail that we walked down along. This is 6th North. Okay, this is the tributary that's coming in Blacksmith Fork. This is the Logan River. And so this reach down here, sort of interesting, right? And so remember what I said about the departure of the thoweg from the center line? Everywhere it's departing, we're getting interesting stuff. We're getting pools and we're getting bars. So we've got a main thoweg here, and then we have some of those secondary cutoffs, and even if we get to a point, I guess here we don't have it, but if you got to a point where there's a mid-channel bar, you might have a braid where this splits around that. Okay, so when we have that mapping of the thoweg, it allows us to differentiate. This is a more refined version of shape into form, and differentiate in orange those riffles where the channel thoweg comes up and over and then back into a pool. Okay, so it allows us to differentiate those from other just sort of other bar features, which might be shown here in red, like this point bar. And then we also can differentiate the bowls in dark blue from troughs, which are just kind of longer plain bed features, where it's just not that well defined. So these, this I'm not asking you to do this sort of a map, but I'm pointing this out because as we come into tier 3 and we come back to that riffle crest, okay, and we come back to this, the different attributes. Well, we could start with, let's start with, there's geomorphic unit forcing, there's the orientation, there's position, low flow water surface slope, low flow relative roughness. Well, let's leave these ones alone for now, but let's just look at some of these, okay? So I'm in this thing, and I'm going to start with orientation, okay? Just to get somewhere. So geomorphic unit orientation, and the orientation doesn't vary for these riffles, right? It's not streamwise, it's not spread out with the crest of the riffle running parallel to the flow. It's not radial, it's not diagonal, it's transverse. It goes across the channel. The riffle crest crosses the channel. Okay, the thoweg that you just mapped goes perpendicular to riffle crest. So immediately I've gone from whatever, like 15, down to 3 options. It's either an expansion bar, a forced riffle, or a riffle. This is the power of this sort of dichotomous key type approach, okay? And then I can look at this and go, well, it's not a mid-channel feature because the position of that riffle, it spans the channel. It goes margin to margin. So it has to be one of these two, okay? So, and then I look a little closer and I can look at the geomorphic unit forcing. Well, a forced riffle is what you get behind or upstream of a channel spanning structural element. We're going to get into structural elements in a moment. But that is a forced riffle, whereas a regular riffle is just a pile of sediment where you have a flow width expansion. So that's what we're dealing with. We're dealing with this. And so I can arrive at, yeah, that is a riffle. And you can use this sort of key, and usually you don't have to get all of the attributes. You get one attribute, and then it filters down real quickly, right? The ones that don't discriminate or aren't that helpful for units, you know, the varies, those aren't going to be where you start, okay? So I do want to point out that one unit that you won't read about in the literature that much, but we've, from applying these sorts of definitions, have realized is really common, particularly in kind of ho-hum, you know, homogeneous plain bed habitat, are shallow thalwegs. And a thalweg, again, being the deepest part of the channel, you can look at, you know, something where like, oh wow, there's the flow is on the outside bend. I might expect a pool out here, but we don't find one. And when we don't find a pool, but we're in that deepest part, and it's concave in cross section, but planar in profile, that's a shallow thalweg. Okay, so it's on the outside bend. It's a place where you'd expect a full bowl or pool to develop, but it doesn't, and you have these sort of kind of uniform profiles, and so that's actually a really common unit, especially in degraded rivers. It's one of the most common things you'll be doing as a designer is thinking about, you know, could I add structure or could I promote processes that would maybe convert some of these shallow thalwegs into a mix of bars and pools. All right. Well, the thalwegs into pools and the bars helping with that. Same sort of concepts can apply for mapping out floodplain units, but we're not going to do it here, just kind of showing you that there's an example there. All right. Now, if we go back to that mapping exercise that you did, I just want to zoom in to a little subreach where we have a really detailed topographic survey where you could do this sort of geomorphic unit scale mapping. So this is where you did that valley setting exercise, okay? So we zoom in, and these colors correspond to what you just learned about, tier 3 geomorphic units. So this is a plan form topographic map, right? The reds are, in this case, little wimpy margin attached bars. The blues, there's not a ton of them, those are pools. And the green and the yellow, those are plain features. So rapids where it's steeper, runs where it's shallower. So anyhow, this is a long profile. This is the top of the reach. This is the bottom of the reach, going along the thalweg. So you can see as we're going through, we get a wimpy pool, plain bed, wimpy pool, little riffle, plain bed, 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 and you know, okay, a few pocket pools. But if I'm a fish, hardly worth noting. Okay, so this is a reach that's in poor condition. We think the reason there's so few pools here is because there's so little wood. Okay, in fact, there's a little symbol for wood. There isn't a single one on here. Okay, not a single piece. And that's despite having a big riparian corridor. So by area, this thing is dominated by runs, rapids, and transitions therein. There's a lot of, you know, pretty wimpy bars just along the edges, along the periphery where little bits of sediments piled up. So this is this same reach after we've gone in and we've built structures that you're going to learn how to build later this semester. So this is adding in some posts, right? These are post-assisted log structures, and then we're bringing in a lot of wood. There's one here, there's one there. What's that? It's a bar, right? What's he standing in? A little bit deeper pool forced by this constriction jet, right? This one's aimed at this bank, this resistant bank. So we just added a whole bunch of wood in here. It's a little bit hard to see, but there's wood there, wood there, wood there, wood there, wood there, wood there, right? These are all structures, okay? And I'm going to ask you to just first look at this versus this. right? A whole bunch more pools, and the pools got deeper, right? And what's happening is at each of the pools, we're building up bigger bars, these riffle crests, right? So we're buying up, we hardly had any riffle, which is good spawning habitat. And now we got a bunch of riffles, and they're making more pool, right? We still have a lot of margin attached bar, but we're picking up a bunch of mid-channel bars too. And so simple addition of wood has pushed this from a poor condition into a moderate condition with a much more diverse range of habitat. Um, so this is the these are a couple other examples, right? And so these are the valley settings, right? And then here's one, and you can see the yellow. It's very, very uniform, just a few pocket pools, right? So this is an area that's just kind of been starved of structure. Even though there's a lot of vegetation that's now growing in the valley bottom, there isn't a lot of recruitment of wood or direct wood in the channel. Versus this is one where some of the structure that's come back and grown, for whatever reason, we've got more of it in. And so we've got we do have a fair bit of plain bed. We do have some, real big riffles, some nice mid-channel bars. So we've got some more interesting habitat. Um, so that kind of contrast of using geomorphic units as a proxy for condition, and then being clear about, in a design context, what is it I'm trying to achieve? Well, maybe I'm trying to shift from plain bed dominated habitat to to having more bars or pools. This isn't a before and after. These are just two different reaches and different conditions, things that you might use as analogs, right? So these are both wandering gravel bed rivers with discontinuous floodplains. These are the flavors of stream, but they look very, very different, right? This one doesn't look wandering at all because it isn't anymore, but it could be. And so this is just helpful for you to understand kind of how you can discriminate conditions with some of these mapping of building blocks. So I hope that's helpful to you. I just want to reiterate that you can do the sort of mapping that we've done. You can do it in detail with, total stations and drones and high resolution topography, but you can also do it just by going out and mapping these things with pencil and paper and recognizing the differences. So we have a tool. It's called the Geomorphic Unit Toolkit, and it applies these definitions that we've talked about by reading topography. That's how you quantitatively do this. I don't want you to worry about that. What I want you to worry about is being able to read and recognize these different landforms and using those to articulate what you're trying to do, what you see, and what you are trying to create through a restoration design. Okay?